Hey, this is Joe Burnett. I want to show you how to write a fleeting plugin. And there's a few things we're going to go through today. In addition to telling you what a fleeting plugin is, I'm going to show you the interface, how to implement it, what it is used for, how it's used, and its capabilities. I'm going to give you a little demo of an actual working implementation and touch on some additional topics. But first and foremost, what is a fleeting plugin? So for that purpose, let me just kind of draw you a little bit of context here. So when you deploy Runner, you have it connect to GitLab. So GitLab is here, and you deploy a runner. Maybe it's in a VM, maybe it's on a local machine, maybe it's in Kubernetes, whatever. And jobs come in, and Runner does some stuff. It uses itself as like a tool to pull in code from the repo, do a bunch of work, and it sends logs back to GitLab, as well as storing artifacts. This is a way to deploy individual runners, and you can deploy as many as you want. But sometimes you want to make use of a more dynamic environment. Maybe you want to create runners on demand, or not consume anything when they're not needed. So there's another way to set this up. It's called autoscaling runners, and it looks something like this. So again, you have a runner that you create, and this runner is going to operate primarily as a manager, and it's going to be getting jobs from GitLab, same as before. This protocol is exactly the same. And it is actually going to be sending logs back to GitLab too. But instead of doing the job locally, a runner is going to create what I'll call a worker instance. Okay, this is some remote machine, some remote environment where it can actually SSH into this thing and drive it through the process of doing the work. So the worker actually does the work. It provides the necessary tokens, et cetera, for the worker to pull down the code and the cache, et cetera. But through that SSH, the logs actually go back through Runner. So this is what GitLab Runner autoscaling looks like. And the reason that it's autoscaling is because the runner, since it's just managing routing these requests and the logs, it can spin up multiple workers. So you can have a whole bunch of workers over here, and it can SSH to each one of them, create them, delete them, etc. So this is the way the Docker machine autoscaling works in Runner, and it's kind of defunct, right? Like it's deprecated and it needs to be replaced. So we have a replacement system that's called fleeting. And I'm going to tell you more about the parts that it replaces and some of its new capabilities too, because it does a little bit more than Docker Machine was capable of. Yeah, in Docker Machine, the way that Runner actually created those VMs is it would actually just shell out to Docker Machine with a whole bunch of details. So you would have to say, Docker Machine, I want you to create, an instance, but I want you to do it with X, Y, Z, the size, the region, everything. You have to give it all the details. So this kind of creates a coupling between Runner and the underlying infrastructure, whether it be AWS or GCP or something else. So enter the new autoscaling setup. Here's GitLab again. And this time, Runner is going to delegate some of the machine-specific details, some of the cloud provider-specific details to a fleeting plugin. So the same deal, it gets a job, it sends back logs, but it actually starts up a co-process, which is the fleeting plugin. And this is what we're going to learn about today. This is what we're going to write today. And what's really interesting about this, the reason why this is you might find yourself wanting to write a fleeting plugin is because it allows you to bolt any kind of compute environment into the runner. this is a very clearly defined interface between these two. It's done with HashiCorp Go plugin as a library. And the interface is defined in Proto, and it creates this abstraction, which is the instance group. So it has a couple operations, this, create, delete, etc. And this plugin here is the one that actually creates the workers. Okay. So this one specializes in AWS, GCP, etc. Cool. So let me show you what that interface actually looks like. So here's the actual proto interface that that is defined in Fleeting. So if you look at this is actually in a library in under Fleeting, under the GitLab org repository. I'll show you where the code is later. And it has a couple basic operations. You initialize it, you update it. Now notice this is a streaming response. So when this is runner asking the plugin for updates. The plugin will actually say, hey, tell me what machines or what instances you have available. This is when you ask for an increase. This is when runner actually says, hey, I want you to make more. I want you to make 10 more of these. And when runner asks for a decrease, it says, here, I want you to delete these instances specifically. And last but not least, of course, that's not useful unless you can use it. So this gets connection info for runner. Now, all of these processes are driven over SSH or WinRM. It also supports WinRM. But so when you get the connect info back, it's the same things you would need for any other SSH. You need a key or a password, endpoint. You need those kinds of details. And that's all inside the connect info. So that's the interface. I talked a little bit about what's inside each one of those. Now, when runner starts, it has a configuration. It has a new configuration entry, which tells it what plugin to start. So if you actually look at inside runner, so we're inside executors, internal autoscaler provider. So this is the internal autoscaler executor actually wraps another executor and gives it an autoscaling environment. And this is actually where we run a Fleeting plugin. And this plugin has a bunch of different configuration. So you'll notice that it has, let me scroll up on my notes here. So for starters, it has a connector config. So you can see here, the Fleeting library provides these details. As I was saying, protocol, SSH, a username, a password, or a key. You really need one or the other. Use static credentials. This is an option where you can have a static key, and this key is of course going to have a public and a private pair. You would put the public key on the machine, on the instances that are being created, and you would have the private key in the runner. And so when the runner wants to SSH in, it would use the key pair, private key, to authenticate to the SSH daemon. But you can do this dynamically too. You can create a key in memory, and you can push the public key through a cloud provider like GCP's metadata service or AWS. The cloud provider will then put the public key on the instance, and then you can connect to it. That's a little bit nicer because the key is only in memory. It's a one-time use key. For my demo, because it's very simple, I just use a static key, and I'll show you how that works. And then a couple, timing parameters. Runner has this same config. It's a different type, but it's essentially the same stuff. And so we just kind of translate it over. So when you actually configure runner in your config.toml, you can put all these parameters in here. So you see here's the connector config, has the same stuff, OS, Arch, protocol, etc., all those things. There's another configuration too that you should be aware of, and that is the plugin configuration. So connecting to these instances is pretty much the same no matter what provider you're using, but providers are going to vary wildly in terms of their API, the information that you need to create those instances. So there's this autoscaler settings map, which is a map of string to whatever. This is very important because what you put in this config, and again, this is an entry in your config.toml for the runner. Whatever you put in this config is going to get kind of parsed and plumbed through to the plugin. So GitLab Runner was able to sort of take this configuration for your plugin and hand it verbatim over to your plugin, so that it doesn't need to know any of those details. It's just pass through. It actually uses it to create the plugin, like to deserialize the object. And I'll show you how that works too in just a minute. So runner stays decoupled from all the details of that plugin. So that's what these things are. You can see that there's a few other parameters here. We'll talk about those when we actually set up the demo. I'll show you what they actually look like, and we'll actually use them. Yeah, so let's go see what it actually looks like to create a plugin. So a plugin will implement a Golang interface. So that proto that I showed you, that defines like the shape of the gRPC, but generated from that, the fleeting library generates this Go library, which really does all the plumbing for you. You really don't need to worry about any of that. You don't need to worry about it being gRPC or the proto or anything. All you need to know is that when you create a plugin, you just need to implement this interface here, provider instance group. And in this case, I called mine a Kate's deployment. Now, when you are building a plugin, it's because you have a bunch of compute resources that you want runner put jobs on. And that can be any compute environment. The only requirements are that you can implement this interface where you sort of keep track of what ones you have. You can create more and delete specific ones and provide SSH access. So for the purpose of this demo, I thought I'd do something kind of unusual, interesting, weird. And I created a Kubernetes plugin. So what this does is this runs in a cluster, and it creates other pods and runs shell commands inside of them. So it's kind of, there's already a Kubernetes like executor, but this is actually treating each pod like a full instance, not like actually going in there and running a container. So you get a shell script and it actually runs something inside a pod. This is, I did it because, it's just not something that exists, so it makes a good demo. And it's kind of interesting just to see what the possibilities are. As it turns out, I didn't actually use a deployment. So this is kind of a misnomer. I just created pods one-off because in Kubernetes, it's a little clunky. If you want to delete a specific pod, you have to give a hint through the annotations when you scale down. And I didn't really want to mess around with that. So I just created pods one-off. You'll see it's actually not that complicated though. Kubernetes has nothing to do with writing a fleeting plugin. You don't need to know Kubernetes. This could like the same plugin you could write for GCP, your own proprietary compute environment, et cetera. This is just about letting runner use some group of instances, some compute environment. So yeah, here's those same proto fields are sort of materialized now as actually like Golang functions: increase, decrease, update. In other words, give me a bunch of information about the ones that exist. Since it's a streaming gRPC, it came back as a function. So you just go over all of your instances and call this function multiple times and then return. And you give connect info for a specific instance when requested, and of course the initialization parameters. So here, I'm going to show you what the create method might look like, creating or increasing. So here you get a specific number. It's just all that is I want you to make 5 more. Runner has its own reasons. It knows why. It's got some jobs. It decided like which ones it needs to schedule things on. Maybe it wants to create some instances ahead of load. It has its reasons. It's doing its auto scaling. All you need to know is that you need to create n different instances. So in this case, I'm just making a pod. I'm giving it a consistent label so I can find them. Some repo, pulling a container. This container is some Linux machine that is capable of running, shell commands. The only thing that you really need in here is either a runner or a runner helper. That's the binary. Helper is just a stripped down version of runner that's able to pull the code, pull the cache, put the cache back up, just do a few of those basic runner like job operations. And you need Git installed on there and Git LFS. So like that, you don't need very much here. Of course, I open up SSH and I run the SSH daemon. So this thing is, as soon as the pod comes up, it'll start waiting for you to make connections and it'll allow you to shell out. I just create it. And if I run into a problem, I return however many I was not able to create. And however many I was able to create. In this case, the iteration loop or n if I finish, and maybe an error. So that's it. The fleeting plugin will take care of the rest. It'll just call you when it wants some. Let me show you another method. So initialization. So notice I'm just kind of filling these out here. Initialization allows you to, it does a couple things. It allows you to validate some of the parameters, set things up, make your connections. In this case, I'm making a Kubernetes connection. Again, Kubernetes is not the important part here, but I do need to sort of set it up and make sure that I can connect. And I can also configure the things that I'm going to use for creation. So notice that I had in the previous example, I had hard coded a repo. It was at the top. But now I actually made it a parameter. So maybe it's important to me which container I'm going to pull from. And so I've created in this K8s deployment struct, which is this is the plugin. I created an exported parameter repo. And this is important. It's sort of like there's a little bit of what appears to be magic here. I'll show you where you actually set this repo when we actually run it. Okay, notice that I check and make sure you provided it, and I'll return an error saying, hey, I need this in the plugin config. Yeah, so the rest of the methods, pretty straightforward. When you call update, as I was saying, you just find all of the things, however you do it. Maybe it's an instance group and you just like make an API call. Maybe you go query them. In this case, I'm querying them by, a label selector because I'm not using a replica set to manage them. I'm doing it by hand. And I just map, the sort of phases of the pod to, fleeting phases, creating, running, deleting. That's it. Just call this function multiple times to stream back the results. I also, you just provide this information, and there's more details that you can add, but it's really just kind of plumbing here, which is great because all the complicated stuff is done once, and you just have to wire things up. And last but not least, let's go take a look at the decrease method. So decrease method is just what you would think. Goes through the instances and deletes them. That's it. And when you ask for connection info, you're asking for one specific instance. So you get that instance, you get that pod or whatever, and provide an IP address. So there's internal and external IP addresses, and you can configure Runner to use one or the other. In this case, I'm keeping everything in cluster, so I just provide the internal IP address. And there's this field expires. This is where you might generate a one-off key. Like when you want to, let me show you an example. So here's our, I'll show you the AWS one. Here's our AWS provider. This is a Go plugin, same as the K8s one that I was just showing you. You have a few parameters, you have the same functions, etc. Notice that under connect info, we get this, we check some stuff, we go to SSH. Oh, I guess I gotta pull it up by hand here. And what we do here is we can actually either parse a key that's provided, right? Or we can generate a key. And when we generate a key, then we actually send it to EC2. And that gets put on the machine itself. So there can be more here in the connect info. Like you can flush it out a little bit with more details. And again, all those details can be cloud provider specific. So for example, in AWS, you can call and list all the instances every time you get an update, but it would be more efficient if you could like use EventBridge to SQS queue and read from that queue and just kind of keep things up to date on the fly and cache it locally. And that's actually what we're probably going to do to make it the AWS plugin specific, but Runner doesn't need to know about any of those details. So there it is. There's the plugin. That's the code. All right. So I showed you one other plugin, which was the AWS one. You could see where it created you could see where it created an SSH key. I'll just give you another example here. This is a Google plugin. Has a different set of parameters. You know, it kind of needs to know the project and the zone, a name point and endpoint, etc. The name of the instance group. So in this case, you know, the AWS one was using an autoscaling group, although we're doing the autoscaling so that it's turned off. In GCP, we're using instance groups. So you'll see all the usual, you know, instance group manager kind of stuff, listing instances, etc., mapping all these different states. So yeah, so that's a Google plugin. So let's jump over to the actual demo. So as I was saying, I've got this thing running in a cluster. So here, here's a list of pods in the cluster, just one in the default namespace called Runner, and that's where I am right now. This has I pulled the code down and so I could like step through it. I probably won't put any breakpoints in right now, but I can run it from here. I've already built the plugin. So when you build the plugin, like notice that this guy is called main, right? And it'll be built as a separate binary and put on the path. So if I was to type in fleeting plugin K8s, right, there's a binary there. I built this exact code and put it here on the runner. It helpfully tells you that you shouldn't run it by yourself. This is part of the Go plugin infrastructure is, you know, you have to, it's supposed to be started from another binary because it starts up the plugin and sends data over standard in and standard out via gRPC. It creates another set of sockets so that it can reroute standard in and standard out and still get error messages. So if you'll see some messages in the logs that actually come from the plugin via those other sockets, even though the direct connection has been used for the protocol. So yeah, you don't run it by itself. You start Runner itself. So I'm gonna run Del, but it's the same thing as firing up GitLab Runner. And there's no changes necessary to GitLab Runner here. Like actually, before I fire it up, I wanted to show you what the configuration looks like. Let me pull up my notes here. There we go. Yeah, the configuration. You should be familiar with this. Most of this, so everything here was actually just generated when I registered this runner. This is pretty generic stuff. I'm totally leaking a token here. Not a big deal, because by the time I upload this video, I'll just delete this runner. It was just too hard to redact it. So don't sweat it. But down here, this is the additional configuration that you create for the autoscaling executor. So it's an autoscaler section under runners. And I want to talk you through a few of these settings, because these are really important settings. These are actually showing not just what the fleeting plugin can do, but some of the additional capabilities of Runner, which uses it. Capacity per instance. So we've actually added a new abstraction in Runner called slots. So a single instance can actually have more than one job running on it. And this is important. We actually built it for our Mac runners, because in a Mac runner, you can have up to 2 VMs. And the Macs take forever to start and shut down. So to save time and to make good use of resources, we actually put a VM inside each one of those Macs to run the job. And we could do 2 of them. So we said, okay, so you could just do N. You can specify however many jobs you are allowed to run concurrently in a single instance, shared in an instance. So this is kind of cool. This is a new setting that you can use, and they're identified by slots, so you can sort of do some resource management. And I'll tell you more about that when we discuss nesting. Max use count. So this kind of determines how many times can you use a machine or an instance before you have to throw it away. If you're doing something like GitLab.com and creating a multi-tenant environment, you really want to use the VM and then throw it away every time, because you can't have the next job have access to where the previous job was, unless you're doing the nested VM thing that I was talking about. But in this case, I'll let them get used a little bit. You maybe put an upper bound on it so that disk space doesn't run out, etc. And of course, max instances, right? You want to kind of always have a max, so this thing, if it doesn't run away from you and create too much cost. And the name of the plugin. Now, when I typed in fleeting plugin Kates in the command line, that's exactly what this thing's going to do. It's just somewhere on the path. That's all you got to know. So this is the plugin that's going to start. Now, here is the plugin config that I was describing. I told you where I was going to show you where it's configured, and this is exactly where. This is the string map that just gets plumbed through. Actually, it's a string interface map, so it could deserialize to anything, even deeper structures. And this just gets sort of laid right on top of that plugin. Those exported fields are the ones that get populated. So when I say repo here, right, that actually goes to the repo field that I was validating. So I've pointed to where I want to get my container, because I've built this image and put it in my container repository. That's why I started the runner for, and I'm also going to use the same image for running the jobs. Connector config. So these are the details about how to connect. In this case, I created a user named Kates that has permission to SSH to the workers. And I am using static credentials, not generating them on the fly. Probably better to generate them, as you could see in the other plugins. And this is where I put the private key and a timeout. So you've already seen this stuff. Now there's another section here, autoscale policy. This should look familiar, because it's actually exactly the same policy as what's used for the Docker machine autoscaling. And you can configure an absolute value of how the idle time, sorry, not the idle time, but the idle count, how many workers you want running in addition to whatever's being used right now. And this allows you to have a little capacity online available to immediately run jobs. You can also specify idle ratio, I think it's called idle ratio, but it's a percentage of your current capacity. So if you say 10% and you have 10 jobs, it'll make 1 more. If you have 100, it'll make 10 more, et cetera. Just kind of give you a specific overhead and percentage. So in this case, I've just configured it just to have 1 idle pod or instance. It doesn't know that it's dealing with pods here. So those policies are exactly the same. So this is my runner config. So I'm actually going to fire this thing up. So I'm starting GitLab Runner. And it's going to read that configuration, start the plugin, connect to it, look for any existing pods. If they're not properly isolated, if we're not using VM isolation, it'll delete them because it can't really trust what's on there. It doesn't know. If it's using VM isolation, it'll SSH in there and delete any existing VMs, but keep the outer instance. So we'll run it. All right, so you notice it started a plugin. That's super great. All right, it's increasing the number of instances. Those are logs from Runner, from specifically the task scaler library inside Runner that uses this. And we told it to keep one, so one idle. So we have a worker already, and it's up and running. Nothing too special there. So I have a toy project called Hello Runner, and this is where I register this runner. So I'm just gonna make a change here. Okay, so let's say, 1, 2, 3. We'll just say 4. I write it, I commit it, I push it, and I look at the logs. So there's a couple things going on here already on the left. You'll see that something's happening. I'm going to view these logs. This one's running. Oh, one of them already succeeded. Updating the job, sending to the coordinator, blah, blah, blah. Okay, well, actually already ran. So you can see Hello Runner. Job succeeded. I think that it ran fast enough that it actually managed to put 2 of them on a single on a single pod. So maybe I need to slow it down a little bit so we can see it scale up. So let's add a little bit here. Let's see, I'm going to say sleep, say 30 seconds, because the runner actually auto scales every 1 second. All right, commit it. Let's see how this works. Git push. Great. And let's just kind of look at the logs here. All right, so we have some pending, some running. Let's see if it. Oh, interesting. They're not all running at the same time. It was doing it earlier. This isn't a battle tested plugin or anything. All right, so this one's sleeping. That's super great. That one is running. Yeah, I'm not really sure why it's not running more than one at once. It's just I probably just messed up the configuration. Yeah. So what it'll do is if what it was doing before is it'll create more pods, like if it needs, and it'll make a bunch of pods, and then eventually those pods will get deleted once the idle time is passed, and it'll scale down to the number. It's the same thing. It's the same algorithm as the Docker machine autoscaler. Yeah, so that's it. That's what it's like to create a plugin. So I want to show you again what that code looks like. It's not that much, you just whatever information you need in order to create and find your instances, and a couple of methods. You have to do it in Golang. Theoretically, you can do it in other languages, but you'd have to implement the underlying protocol stuff. It's not really worth it. Yeah, so that's a plugin. Yeah, I mentioned nesting. So slots come in handy, in particular when you are running VMs in an instance, because you're gonna really be slicing out a piece of the machine, and you don't want to put too many. Like in the case of a Mac, if you try to create more than 2, it'll give you an error. So if the runner reboots, it forgets about what's on that instance. And so when it starts scheduling more work, like in the case of Mac, if it schedules another job on a Mac that it found, if it specifies which slot it's intended to go, 0 or 1 if you have, capacity per instance of 2. More, of course, 0 indexed. And if there's already a VM in that slot, because there's an agent on the Mac, if there's already a VM there, it will delete it before it creates the new one. So it kind of cleans up lazily. Yeah, so that's VM isolation. There's another, if you go back and look at the runner config, there's another stanza, which will tell you how to do the nesting. And nesting is a library which has a client and server. The server is an agent you run on the worker itself. So it's a little slice of control plane, and the client is built into the runner. And after it gets into the instance, it'll do another connect from the client to the agent to create the VM, and then SSH again, tunneled into the created VM. So check out nesting if you want to know more about that. Docker autoscaler is another executor. So what I've shown you here is the instance executor, which assumes that the execution environment is a whole instance. It's a new one. There's another new one called Docker autoscaler, which is basically the thing is Docker machine, but it replaces it and uses this new autoscaling system. Instead of connecting and running shell commands, it uses SSH to tunnel in, connect to the Docker socket, and run a container. So check that out. They are documented on the website. So if you go look at runner executors, you'll see 2 experimental ones there, instance and Docker autoscaler. If you want to see if you want to know how to work on this system, like the larger part of it, the actual task scaler, runner, fleeting underlying mechanics, there's a whole description of how to do that in the runner development docs. And there's a link to the section. And of course, here's a feedback issue. So if you start using this or have a use case that either works well or isn't satisfied by this new auto scaling system, you can tell us what's going on. It's pretty easy to change things at this point because it's new code and it's pretty early on in the process. And as you can see, we've really pulled things apart so you can move them very independently. The auto scaling part is completely pulled out of Docker machine into the task scaler library, totally separate. So you can use task scaler on any executor, and the cloud provider specific stuff is really pulled out into fleeting plugins. So yeah, tell us what you think. It's not hard to make changes. And of course, I have all the code used to create this demo and this plugin here in this repo, fleeting plugin Kate's demo under my name, Joseph Burnett, on GitLab, including these notes if you want to look at some of the links and where the code was. Yeah, so that's it. That's how you create a fleeting plugin, and more about like what it can do and what the runner can do with it. So hopefully it's helpful for you to understand fleeting plugins. If you want to use one, if you want to use an environment like AWS, don't build your own, use the one that exists already, because there's lots of effort already put into it. If you want to create a new one for a public cloud that doesn't have a plugin yet, please share it. That would be lovely. We can all work on it together. And if you do want to create one for a proprietary environment, that's fine. You don't have to share the code. Runner will be able to work with it regardless. All I have to do is import that fleeting library, and it's all negotiated over gRPC. So there'll be the same method for avoiding breakage and deprecations as for any gRPC service. So yeah, I hope you enjoyed hearing more about fleeting plugins. I hope you build one. I hope you use one. And I hope that this also really helps us consolidate and improve our runner infrastructure. So thanks for listening.